So this unit 3.1, is about cross-validation. Now, why do we care about cross-validation and what is it? Well, basically, cross-validation is preparing the sample observations for learning. And sometimes when you don't have enough data to work with, you want to learn on as much data as you can, but you also need to hold back some data for testing too. So cross-validation is one popular strategy for preparing data for learning, to find the best model with the given method that you have. So let me give you an example here. It's probably the best way to explain this. And cross-validation is something that we'll be using for all the different use cases that I have shown and will show in later units. So let's say we have 100 observations. And first thing we're going to do is hold back probably 25% of those observations for testing. So out of the 100 in the stack here on the left, we're going to take 20 and put them into the test data. Okay, we're not going to learn from that data. So that's unseen data. The remaining 80 now are going to be divided into what we call folds. So K folds would in this case be 10 folds. Now you can use 2 folds, 5 folds, 20 folds, as many as you'd like. We see 10 as kind of being a pretty good standard, I guess, for the kinds of use cases that we have in the pipeline industry. So if we have 10 folds, that means we're going to take the remaining 80 observations, divide them by 10, then we end up with 8 observations in each fold. Now, the next step is to learn a model, is to learn a model based on 9 of the 10 folds and then test it against one of the outstanding folds. And we do this 10 times. So in this case, what I'm showing you is this top fold is the one that we're going to validate against, and the other 9 are what we're going to learn the model against. Then we're going to learn another model with the 8 here at the bottom and the 1 at the top, and then the second one down becomes what we validate against. So we end up, in this case, with actually 10 models with 10 performance vectors. Okay. Now the question is, where does this go, and what do we do with this? Because the whole point is to leverage all of the data as best as possible and not hold out data and not learn from it necessarily. So what we do is we take all of the data, learn a model, and then the performance vector for this resulting model is the average of how each individual model performs for each K-fold. Okay. So scooting over here to the right, you can see that we got our learner or method, and then we create many models, but we really end up with just one model out of this cross-validation process. And then we end up with one learning performance vector. That's the average, in this case, of the 10 folds. This model, once it's been optimized through the learning process, and by that, just to recap, that would be finding the best parameters or best coefficients, the best fit of the data with the given method. Once a model is learned, then we can test that model against the held back unseen test data and see how well it performs with data it's never seen. And it's this performance vector that typically is the vector that's used to decide whether to deploy or use the model or not. So this is cross-validation, common practice for preparing data for the machine learning process. There are other sampling techniques that are available out there, so you do have to make a choice, what you're going to use. But we find this one is probably most applicable, most robust for pipeline integrity and risk use cases.